So here we're talking about, is this a relationship shown by the data? Is it linear? What does it mean to be linear?
To be
Mike,
Constant, proportional.
what's constant in a line?
All the data points have to be proportional.
So all the data points have to be proportional. So are you saying that?
The rate of change has to
Okay, that's even better. The rate of change has to be proportional. So but you bring up something different. So let's say we had a table, okay, and all of our points were proportional. So let's say we had 2, 4, right? So if all of the points were proportional, 6 would go to what?
12. I can't think of that.
And -3 would go to -6. So that first thing you said where the points are proportional, like my y's over my x's, that's something that we've talked about already. That equals, what we're saying is in this constant, in this table that equals a constant, and we had a special name for this. Anybody remember what that was? Not direct variable, but a direct variation.
I meant variation.
Does this direct variation produce a type of line for us?
Yes.
Sure it does. Why, Preston? How do we know it produces a line?
Because pretty much x over y for every single point you could say is equal to the same thing.
Right, so not x over y, that is true, but what we're interested in is y over x, and that goes right back to what Mike said about the tables up top. About the table up top, and then we're not looking for the ratio of y over x, we're looking for the rate of change. So we're looking at the rate of change for the y versus the rate of change for the x. So we're talking about, we want to know, is the slope constant? So that's the change in y divided by the change in x.
So are we doing that y1 minus y2?
So Risa asks, is it y2 minus y1? Well, what is the change in y? What does that mean? What does it mean to look at the two changes in y? So how do we find the change in y between 7 and 3? How do you find the change? Johnny?
You could add the numbers and get the
What do you mean add the numbers?
Never mind.
You subtract. So this is really just, the change in y is really y2 minus y1. Right, and the change in x is x2 minus x1. But what do we know is that this slope must remain constant. Yeah, constant in the whole table. So that's what we have to check for. Here, the change is 4, the change is 4, and the change is 4, and here we see a change, but these are all, make sure we talk about directional, so those are positive changes. Here we change positive 1 each time. Right, so what's our rate of change? 4 over 1, so m is 4 over 1 in every case, right?
Yeah.
Let's take a look and see about something that might have a bigger value. So let's go from the first point to the last point. What's the change from 3 to 15? 12. The change from 2 to 5 is 3. So the rate of change here is 12 over 3, which is the same as? Right. So what we're saying is the change, the rate of change is proportional. That's what makes things linear. The rate of change for every point in our situation, all right, is in this same ratio. It all equals the same value. So it's kind of like that direct variation, except the only difference is in the direct variation, all of my entries, y's over x's, equal the same value. And in general, to be linear, okay, our change in y over our change in x's have to be the same value. Which does happen here, in this situation, but it can also happen here where the y's and the x's do not equal another y over another x. Because we see that 3 divided by 2 does not the same as 15 divided by 5. So we know that that is not a direct variation, however it is linear, and we've shown that here because for everything that we can see, the slope is 4. How about number 30?
The y goes to...
What do you think, Risa? Okay, Giovanni, why is it not linear?
Because y
Okay, so this goes up by 2, then it goes up by 1, and then it goes up by... Is that what makes it not linear? No, because what do we need to compare that change in y to?
Change
We need to compare it to the change in x. So that negative 3 over negative 1, that's a change of 2, positive or negative? It's a positive change. And these are all positive changes also. And from negative 1 to 1? 2. And from 1 to 3? 2. So now we can see that it's not a line y.
Because they don't, or they're not constant,
What's not constant?
the x and y values.
Well, the x and y values weren't constant here.
The rate of change.
Like,
The rate of change. So if you look at this here, this 2, that's the change in y, that's the change in x. So for between these 2 points here,
that's constant.
the slope is what? What's the slope? 2 over 2, which is 1. But what about between these 2 points here? Between those 2 points, what's the slope?
2 over 3. No,
What-
3 over 2.
Right, 3 over 2. We want to make sure it's always our change in y over our right changes in x. So because it's not constant throughout the table, we know that this is definitely not linear, right? How about the next one? Somebody new, please.
Oh. I know this.
For 31, go ahead, AJ.
On the y, it's decreasing by 4.
So the y is decreasing by 4. So here we're going down 4, and then here we're going.
Down 4.
Is that down 4 from 8 to negative 4?
No, it's going down 8. No, it's not. It's going down 12.
12, right? Again, we just want to make sure that we check every point on the table. And from negative 4 to negative 8, it goes down 4. Again, we need to make sure we have direction here. Because again, we know that was another way that we talked about slope. We talked about slope as, right, rise over run. So we want to know if when we're rising, we're actually rising, or if we're actually going down. And that's what these signs here will remind us. Now, how about the x direction? Somebody new. Somebody new. Lewis.
The first one is going up. Is it going
Sure, yep. Negative 4 to negative 1 goes up how many? 3. And again, I'm going to put a little plus 3 so I know we're moving in a positive direction.
and negative 1 to negative 5 is
Yeah, well, to positive 5, you're right, it's a positive 6. And here we have 5. So let's see.
the rate of change is not constant.
The rate of change is not constant. What do we see? We see here the rate of change is
Negative.
negative 4 over 3. And then we see it's negative 12 over 6. And then they try to tell us that it's also negative 4 over 5. Right off the bat, I know that these aren't equal. How do I know? Look at this. Is this bigger or less than 1? Less than 1. This is bigger than 1. So even if I'm not sure about simplifying fractions, I know that because this is less than 1, that's bigger than 1. Another way we can check to see if these are the same, somebody used the word proportional before, and we're going to stick with that. How do we know if these two are in fact a proportion? Cross multiply. And because we know that the cross product in any proportion should come out to be the same. So negative 12 times 3 gives me negative 36, and negative 4 times 6 gives me negative 24. We see that those two cross products are not equal, and it tells us that we don't have a proportion. Our slopes are not the same in every case. So again, we have a situation here that is not linear. The slopes are not proportional, so it is not linear. The slope doesn't stay constant. Okay? And all proportional means is it could look bigger, but it's really just the same. Right? Because if we had 1/2, when I say look bigger, give me something that looks bigger, but it's the same. 2/4. So we could have a slope that was 1/2, or we could have a slope that was 2/4.
It's still
And it would still be on that same line as long as those points gave us the same slope. Okay, let's look at the last example. And Johnny, you said it's crazy? What happened? Talk to me.
Okay, so, I know this last time wrong. Obviously,
It's alright, so what do we want to look at first? The change in y's or the change in x's?
the change of y,
Alright, so tell me.
for 5 to negative 5, and
From 5 to negative 5, we go
negative 10.
down 10. Okay?
From negative 5 to 8.
Negative 13, go
8,
down 8. And here we go
down 8.
down 8. Doesn't seem so crazy right now. Now what? What's next? Negative 2 to 3 is a total of increase or decrease? Okay. And then 3 to 7? And 7 to 11? 4. So let's check our slopes. Let's check our ratios. Change in y over change in x. What does it equal in the first case? Negative 10 over 5. In the next case?
Over 4. Negative 8 over 4. Wait, doesn't mean it's proportional if they can all be divided by each other, like 5 can be divided by 10.
Well, it just if they're the same ratio. So are these the same ratio?
Yeah.
How do we check if they're the same ratio? There's a couple different things we can do. We can simplify. If we simplify this, we get 2 over 1, which is, what's 2 over 1? 2. So here we have negative 2. Here we have negative 2, and here we have negative 2. So I know that my slope is negative 2. If you don't know how to simplify or you forgot how to do it, take the cross product. Take these two guys. Say, hey, are my slopes proportional? Are they really the same thing? And what do? Again, I check the cross products. And I see that we have negative 40 equals negative 40. So sure. The slopes are the same. And I have a line. So now let's just recap. Let's write all these down because I'm going to run through again what your homework was and basically use a table. So now we'll have another trick. Here we had a slope of what? Anybody remember? 4. Here we had a slope of, why nothing, Allie? They weren't the same slope, so here we didn't have a line at all. So it's not worth it for us to try to find an equation. How about here?
Wasn't linear. So
Was not linear. So forget that. And here we said the slope was
negative 2.
negative 2.